Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on binding energy per nucleon curve. We have already done what is mass effect. Actually, it is the difference of mass of nucleons constituting nucleus and mass of the nucleus as a whole. And energy corresponding to this mass effect is known as binding energy. Actually, binding energy is the minimum energy required to break the nucleus into its constituents. अगर मास इफेक्ट जीरो हो जाए तो क्या होगा? बाइंडिंग एनर्जी जीरो हो जाएगी, इसका मतलब न्यूक्लियॉन्स को बाहर निकलने के लिए न्यूक्लियस में से वही एनर्जी रिक्वायर्ड नहीं है, तो न्यूक्लियाई क्या हो जाएंगे? अनस्टेबल. सो एक्चुअली इट इज सिग्निफिकेंट इन डिफाइनिंग द स्टेबिलिटी ऑफ न्यूक्लियस. And more important term is binding energy per nucleon. ये कैसे मिलती है? By taking ratio of binding energy with mass number. Now, what is binding energy per nucleon curve? Actually, it is the graph drawn between binding energy per nucleon taken along y-axis and mass number taken along x-axis. This will be the shape of curve. Just observe this shape. And we will discuss characteristic features of this curve and then we will draw certain conclusions from those features. Just observe here. For nuclei having mass number lying between 30 and 170, but you find that here the binding energy per nucleon is almost constant. That means binding energy is independent of atomic number for nuclei lying between mass number 30 to 170. And it is maximum for iron 56. Its value is near about 8.8 MeV. Actually, it is 8.75 MeV. And for uranium 238, its value is 7.6 MeV. Now, just observe here for nuclei having mass number less than 30. What you find? These nuclei, they have less binding energy. So these are unstable. Similarly, with mass number greater than 170, the binding energy is less. So these are also unstable. To obtain stability, these nuclei will make some other nuclei which are comparatively stable. They have more binding energy per nucleon. Now, there are also peaks corresponding to nuclei helium 4, carbon 12, and oxygen 16. So they have more binding energy per nucleon than their neighbors. So these nuclei are more stable because they have more binding energy per nucleon. Now, what conclusion we can draw from this curve? First, the force between nucleons is attractive and it is sufficiently strong and it produces a binding energy of a few mega electron volt per nucleon. A particular nucleon, in case of sufficiently large nucleus, will be under the influence of many nuclei, but only nearest neighbor will have impact on it, which come within the range of nuclear force. जो तो nuclei, nuclear force, nucleons जो nuclear force की range में आते हैं, वही nucleon एक particular nucleon को इफेक्ट करेंगे एक बड़े न्यूक्लियस के बीच में. सारे न्यूक्लियन इफेक्ट नहीं करेंगे. और अगर किसी न्यूक्लियस का डिस्टेंस, न्यूक्लियन का डिस्टेंस उस न्यूक्लियस में एक पर्टिकुलर न्यूक्लियन से न्यूक्लियर फोर्स की रेंज से ज्यादा है तो वो उसको इम्पैक्ट नहीं करेगा. The property that a particular nucleon influences only closest neighbors is known as saturation property of the nuclear force. यहाँ से पता चलता है कि nuclear force saturate in nature. Because there are some peaks on this binding energy per nucleon curve. So they are more stable as compared to neighboring. That is why alpha particle, which is lying at one of its peak, is extra stable. Now, having nucleus like uranium, it has less binding energy per nucleon. So it is unstable. To attain stability, it undergoes fission. It breaks up into two certain nuclei which are comparatively stable. So binding energy per nucleon of daughter nuclei will be more as compared to parent nucleons, as a result of which nucleons will be tightly bound. And it implies energy would be released in the process of fission. Similarly, in case of nuclei having mass number less than or equal to 10, there is less binding energy per nucleon. So these are also unstable. To attain stability, they will fuse together. They will combine together to form comparatively stable nucleus. And binding energy per nucleon of daughter nucleus will be more than parent nuclei. So the nucleons will be bound more, as a result of which they will attain stability. And in this process, large amount of energy will be released. This is the cause of emission of enormous amount of energy in case of fission or fusion. Thanks for watching this video. Like, share, subscribe my channel.